This is going to be a difficult video to make, simply because every topic about it has already been covered once before. I mean, let's talk about the IBM PC, the 5150. I guess maybe the 5160 if you want to. What is there to talk about? There's already countless videos there talking about the history of the IBM 5150. There is countless videos out there talking about how MS-DOS is PC-DOS, but relicensed. Like, even the hardware is synonymous with the PC platform, and yet there's countless videos on every single aspect of that machine. So it's really difficult to actually try and talk about it, because you just plunk the machine down, and what are you going to do? Okay, well, you can turn it on. Ooh, here's the startup, the memory count, here's DOS, here's the hardware, here's like the basic DIR, it's DOS, whatever, we get it. We get the hardware, like we've talked about that. So, you see my struggle here? It's difficult to talk about the PC because there's not really anything captivating that hasn't already been said before. Now, that being said, between 1979 and 1983, 1984, there was a point of critical mass. You see, IBM was not the only person that was manufacturing personal computers and office computers. Yes, there's the PET, and there's like smaller machines like the Apple II and stuff like that, which are all over the place, and they can be considered business computers as well. But specifically, to be a personal computer and running on an Intel 8088, there was actually a number of companies that were coming out with machines not only after the IBM 5150, but also developing it at the same time as the 5150 was being manufactured. So of all the computers that you could possibly choose from, I decided to choose on a product from a company called Sirius Systems. Sirius Systems was founded in 1980 by Chuck Peddle of MOS Technologies and the Commodore PET notoriety, as well as Chris Fish from Commodore as well. They wanted to build their own personal computer company now that Commodore was doing their own thing, but they wanted to be a little bit more premium, a little bit more exotic. They wanted to make things their way. And at that time, not a lot of people were really looking at IBM at what the heck they were developing, because the closest thing you had early on was the Data Master, which is nowhere near similar to the 5150. And then when the murmurings and announcements that IBM was in fact working on a desktop office and personal computer, then things began to become kind of uncanny. But still, we were dealing with a product that is mostly different from the 5150. So let's talk about that machine. This machine right here is not an IBM PC. This here is the Sirius 1 computer. Okay, this one here says Victor 9000 on it and has Victor on the keyboard. The idea here is that in 1982, Sirius would purchase Victor, and they would use them for rebranding and redistributing these machines throughout the rest of North America. But what you're looking at here, while it looks very similar to the IBM 5150, is not really all that similar to the IBM 5150 once you get beyond the fact that both machines use the Intel 8088 microprocessor. The base configuration of this system starts with 128 kilobytes of RAM. You can expand this up to 896 kilobytes, smashing through the 640 kilobyte limitation. And that's because the BIOS on here isn't even remotely similar to anything IBM has. Even the monitor we're going to get into here is not just an MDA display at its base configuration. We do have two floppy drives on the front of this, and this can be configured either with one single-sided floppy disk drive, 5 1/4 inch at its minimum configuration. We can go with two double-sided floppy drives if we want, or we can actually add a hard drive either internally or externally to this machine. For today, we're going to be dealing with a single-sided and a double-sided floppy disk drive. And your choices in operating systems consisted of either Digital Research's CPM86 or Microsoft's DOS. I don't actually have a non-OEM version of MS-DOS from this time, but you got to understand me here. It's funny that I actually bring up this piece of IBM PC-DOS here, because PC-DOS doesn't run on this. So let's talk a little bit more before we go on any further with this machine about what exactly is IBM PC compatible and what's MS-DOS compatible, because it's very important to what kind of software was going to run and work on the Sirius 1. It is stated repeatedly in the history books that IBM is paying a licensing fee to use MS-DOS, rebrand it, and ship it with the IBM PC as PC-DOS. There was nothing in that contractual obligation for Microsoft to exclusively sell the rights to MS-DOS to IBM. Microsoft knew better. And as a result, really, anybody who wanted to run MS-DOS on their computer could do that. And you weren't necessarily limited by the hardware architecture of the machine. It didn't need to be an 8088 or an 8086. You could have it on a Z80 or a 68000 or a 6808, I bet you. What it comes down to is that MS-DOS supplies for all vendors a hardware abstraction layer. You know, like instead of talking directly to the hardware with your software, you're talking to drivers. Basically what we've been doing with computers since the beginning of time, really. The reason for this here is that well-disciplined software doesn't talk to the hardware. Instead, it talks to MS-DOS, and then through that abstraction layer and the drivers that are supplied by the vendor, that then talks directly to the hardware BIOS and the hardware within the machine. So that means if it says on the box that it runs on MS-DOS, it'll run on any device that runs MS-DOS. But something weird was happening here at the same time. Where does IBM PC compatible come in? So when you're dealing with a machine that has like 4, maybe 5 megahertz of total CPU speed and like a few hundred kilobytes of RAM, resources are tight, resources are limited. You need to figure out a way to make your application stand out amongst the competitors by making it faster. The MS-DOS compatibility layer is actually somewhat slow for what it does. And so what most people did is that since there was no hardware, device, or memory protection at the time, you could completely ignore it and just have the application skip over DOS and talk directly to the hardware. Remember how I said that there was a point of critical mass with all these personal computers coming up onto the market at the exact same time? It could have gone any direction. The only reason that it seems that we call everything IBM PC or 100% compatible is because IBM, like Apple today, when IBM did something in the early 1980s, everybody looked and everybody followed. And as we saw with the IBM PC, everyone cloned the absolute hell out of it because of its open design. And as a result, a lot of vendors and software developers looked at that and said, I don't need to use the penalty that is the hardware abstraction layer. I'm just going to talk directly to IBM hardware, because then all of these countless millions of IBM PC and XT clones are all the same hardware. My software is going to be pointing at the same registers, addresses, and devices, regardless of who's making the system. On the downside, however, it means that systems like this, the software doesn't work onto it. And in fact, with these machines, since there is no requirement by the vendor or by the manufacturer to comply with IBM's hardware standards on where everything is within the memory map, you can, for example, send something from your application to what you expect is the memory location for your CGA display, and in fact, you're trying to write to a location in ROM, and it'll just not work. Worse yet, it may just very well just crash and do absolutely nothing at all. So that is where MS-DOS compatibility comes in, and that was the main downside and the downfall to all of these non-IBM PC clones. It didn't matter how much nicer they were, how much better spec they were, even if they were cheaper. If they weren't a clone of the IBM PC, many of these companies did not succeed or go anywhere. In fact, with Victor, they started in 1980 and they were closed by 1984, but not before they were able to logistically get systems moved to the other side of the planet. So ultimately, the Sirius 1 and the Victor 9000 were not commercially successful in North America. In fact, Victor was able to spin itself off from Sirius when it collapsed, and I think to this day it's still supplying basic office materials, you know, like desks, calculators, stuff like that, but they've long since exited out of the computer business. But there was still a market that IBM wasn't able to crack in time, and as a result, these machines sold fairly well under the name Sirius 1. IBM, for reasons I don't understand, took 16 to 18 months to get their 5150 to European markets. So for everyone that was west of the Berlin Wall, like the United Kingdom and the Netherlands, Spain, France, all those places, you could go to a store and you could actually buy a Sirius 1. They were being distributed by a number of different companies, but in the United Kingdom, I actually have numbers for this. By the time IBM launched the 5150 in the UK, a company by the name of Applied Computing Techniques, who was selling the Sirius 1 as the ACT Sirius 1, already had about 33% of the market. And that's up against the Amstrads and the Sinclairs and all the other microcomputers that were available at the time. So there was a sizable chunk here, and they would actually go on to be so financially successful from this venture of distributing North American Sirius Victor machines that they would go and develop their own system. It wasn't IBM PC compatible, but at this point here, IBM PC compatibility didn't matter. They just had so much of the market, they could do whatever the heck they wanted. So that is why for you European folk there, you may recognize this system a lot more than you do the IBM 5150 and the countless clones. That's not to say that you were going to be completely flooded with clones by the end of the 80s, but these machines for a while were all over the place. And so that's why if you remember as a child you were working with a PC and it didn't feel like a PC, it may very well have been because it was a Sirius 1 system. So for the remainder of this video, we're going to talk about this like it's a Sirius. Basically, everything is exactly the same. The case is going to be slightly different, and the color shadings are going to be a little bit different here. But the monitor, the internal hardware, and the keyboard, everything is the same. But now, let's dig into the hardware. And the first thing that we're going to talk about is, of course, the keyboard. This is a very interesting device here. When you think of an IBM PC, you usually are used to the layout that you would get. So this is QWERTY, not QWERTZ, but otherwise the extra function keys here are very specific to the non-IBM fashion of the Sirius 1. So clear home, scroll up down, text reverse on and off, underline control on and off, and repeat. You have an alt key, you don't have a control key, you have a delete key. Things are getting kind of weird here, and also you have a double zero key instead of just a zero key, which is right there. And you can also kind of see right here that I have controls for contrast, brightness, and volume. And that's just simply because with this monitor here, which we will dig into, this has no knobs or dials or controls on it. This is a software-controlled monitor. The brightness and contrast are done by the keyboard. As a result, this is kind of important. You need to keep the keyboard paired with the machine. Without it, you can't control the screen. So what I'm trying to say here is if you find one of these machines, don't separate the keyboard. You know who you are. The key switch technology, by the way, I have to talk about this, instead uses foam and foil pads. Everybody hates these. TechSelect sells replacement pad kits. These are the pads here that I manufacture myself with a punch in that. I did a YouTube video on this a while back, and that just explains how easy it is to make these. And I've gone through, and this keyboard works perfectly fine now. It's a keyboard. What else can I say about it? The monitor, like I said, super funky. So it sits on this plastic base right here. I can separate that if I really want to. But the idea is that as it's sitting on that base, it can rock back and forth all at once in a weird, not monitor-like fashion. So that's an interesting design base. There's also a peg that sits on top of the machine here, and that allows me, when I place it, not only to center it on the top of the system, where is it? There we go, but also rotates it on that one peg there. So the monitor's not at risk of any time of falling off. The monitor has a anti-glare screen on the front of it. It's kind of difficult to show here, but that's why it doesn't look as reflective as you would normally expect these monitors to be. It is a green phosphor monochrome. And if I go with the screwdriver, it's also incredibly easy to take apart. And I have to back that one out, and off it comes. And there we go. There is not a hell of a lot inside this monitor. In fact, there's the analog board just living right over here. There's a little board that extends right here, which is the software control for the brightness and the contrast. And the whole thing just kind of falls apart in your hands. In fact, for that screen on the front, this one here has dust on it. And if you wash it off, well, then you have to deal with the fact that there's going to be fluid or liquid or some sort of cleaning material on the front here. So usually it's suggested you take the screen off. Is that a problem on this monitor? No. Put it on its face, which, by the way, isn't directly touching the table. Loosen that screw. Loosen that screw. Loosen this screw. And loosen this screw. That comes off there. And there's our screen. I can take that off, clean it, and when I'm done, I can just drop it right back into place. And you may have also noticed it already, there's no other power connector on this monitor here. There's just the one cable. So the computer is not only serving double duty here as supplying the video signal for the monitor, it also supplies power over this connector here. It is a 9-pin D-sub connector with 1 pin removed out of it, and instead of having thumb screws, it has these little tiny grippy clips on either side that when you put it in, it clicks into place. So give me a moment here. I'm going to clean this up. Actually, before I clean this up here, there's also another thing that's worth pointing out. Everything has date codes. So this monitor here that I can tell from this piece of plastic injection was manufactured January 28th, 1982. I don't even think the IBM 5151 monochrome monitor is this easy to service. Also, the plastics on this hold up extremely well. So not anywhere near as brittle as an IBM 5151. It's an excellent screen. It's fairly bright. I'm going to talk about that later. The plastics are durable, but again, it's kind of proprietary to the machine. So don't separate the monitor from the computer if you don't need to. And last but not least, the CPU itself, whose plastics are holding up incredibly well for 42 years old. I know stuff that's half that's already becoming brittle. This is great. The plastic shell is actually around a metal skeleton that sits inside of it, so you need to understand I'm also missing parts of this as well. There's supposed to be a back cover on this computer that would give me the proper port designations and everything, but we're missing that. So instead, I had to label these. So we have 2 serial ports on here. Those serial ports, by the way, are the opposite gender from what you would expect of RS-232 ports on an IBM PC or compatible. This is our video connector here. It's our 9-pin with the weird not thumb-through screw things. And then our parallel connection right there. That does not look like a 25-pin connector like we're using for the serial ports here. And that's again because this isn't an IBM or an IBM compatible product. Sirius can go and do their own thing, and who's going to stop them? So instead, it is using the 36-pin Centronics connector that you typically find on the back of a parallel printer from that era. You require this cable, which is a 36-pin Centronics on both sides, to plug it into a printer. And you know what? That's fine. That's okay. This works all right for what it is, and that means you can't accidentally plug into the other 2 serial ports. So that was well thought out. There is a red button here. That is our reset button. I've actually had to add that in there because the original reset button was broken off. So this one here doubles the duty as a reset button. And then lastly, we have an RJ45 connector right here, which is where our keyboard plugs in. Above that, I have this opening here. So there's additional expansion boards that can interface through a bulkhead to the outside world right here. And there were a number of features that were available that you simply did not find in a stock IBM 5150, or any PC clone for that matter. You could get high quality digitized audio in and out. You could have a touch screen, you could have an enhanced color monitor, and you could route all of that through this port right here. It's also worth noting the fan on this thing here is an AC fan. And also, half of the vents on one side of here are taped over as if they needed to, for some reason, change the way that air pressure exited the power supply. Because as you'll see, the whole back of the machine here is mostly power supply, except where the fan is. Now, opening the system up here, I haven't grabbed my screwdriver at all yet, and that's because the cover's already missing, so there's 4 screws right there. So if I want to open the machine up right now, grab the sides, pull back, whee, and there we go inside. And the first thing that we are dominated by is the circuit board that's sitting on top. Truth be told, the floppy drive in this is probably the most cursed, most weird, most amazing floppy drive I've ever seen. This thing kind of puts the Twiggy to shame for just how much data you could store onto a floppy disk, and yet at the same time, it's using standard tandem double-sided and single-sided floppy disk transports. It's just the rest of the hardware on here that has been changed. The eagle eyes here may notice 0, 1, 0, and then nothing. This drive right here is a double-sided drive. The drive on this side here is a single-sided, hence we're missing head number 1 on this drive. These drives, so how do I explain this? Because even the sheer number of times I've tried to practice this one here, it's cursed. So normally when you deal with a double-sided, double-density floppy disk, you can do, 180 kilobytes on a single side or 160 kilobytes, and that becomes, 360 kilobytes on a double-sided floppy disk on the IBM platform. Even though you're running MS-DOS on this machine here, this floppy controller, which is what it is doing some really weird magic, because this is doing both variable speed recording, something that you would expect to find in the early 400 kilobyte Apple Macintosh drives, the 3.5-inch stuff that Sony was supplying, and it was also taking a page from the floppy drives that Commodore was shipping for the PET, and of course there was like the 1541 with GCR. So this is doing variable speed, what was it? It's not GCR, but the point I'm trying to get to here is that the maximum capacity of a double-sided disk was 360 kilobytes on the IBM PC. It was like 100 and some odd K on an Apple II. If you took this disk and you put it into the single-sided drive on this computer, you could format that to 600 kilobytes of data. That's a lot of storage, and that's just a single side. If I were to take the same disk, and granted it has no bad sectors on it, and put it into the double-sided drive here, this computer will format that double-sided, double-density, normally 360 kilobyte floppy disk to 1.2 megabytes. That is an astonishing amount of data that you can store on a floppy disk in 1982. And remember what the Lisa had to go through in order to get 1.2 megabytes or something close to it onto their disks. And those are high-density disks, so those are even less reliable than this. And yet somehow it works. The downside, however, is that because it doesn't need to care about IBM PC compatibility, any disks that you format in this machine will not work in any other machine besides an ATC Sirius 1, the Sirius 1, or the Victor 9000, or any of the equivalents that were being shipped around Europe at the time. It also means that disks that are formatted to a standard PC format, be it whatever it is, won't work on this. So there were many years where it was actually very difficult to get software for these machines and have it transferred over. I got incredibly lucky with this. It came with MS-DOS and Kermit already on a disk in the drive when I got it, and it worked, and it spooked the hell out of me because I wasn't expecting it to be in there. The other board that you see in here, this thing right here, is a memory expansion. This is, by the way, the Sirius's solution to not having an ISA bus. This is the expansion connector, and this is where all of the additional peripherals and add-ons would plug into. This is a 128 kilobyte RAM board. I have 2 banks here of 64K X1 chips. You need 8 of them to get 64 kilobytes, and there is 16 on this board right here. So when that goes in, it's also notched in such a way that you can only put it in one direction, otherwise it doesn't clear the speaker. We can also see the AC fan in here as well, and this board that just fell in there. Oh, that's totally fine. Normally I complain about PC cases about how unsurfaceable they are, but as we saw with the monitor, these systems are actually not that bad, at least to get into the monitor. the PC and the CPU here to get down to the actual motherboard, oh, this is great. This is fun. So let's say we want to take off the disk drives. I don't have to take off a bajillion screws. In fact, I don't have to take out any screws at all. I'm going to take the internal header here, which connects it to the motherboard. I'm going to unplug that. I'm then going to go and unplug the power connector. There are 4 screws. So 1, 2, 3, and 4. And all I've done here is I've just loosened them. I haven't actually taken them out. And then I can simply take the machine, and there we go. The whole half of the machine just separates like that. And now we can see the floppy transport, we can see under there, we can clean it, we can service it. There's our speaker, but also now I can go and retrieve my memory board that I accidentally dropped in there by accident, and oh look, there's the motherboard, but there's still more that's hiding underneath of the power supply. No problem. Same thing as before. I'm going to take the 4 screws that are on the back of this machine. I'm going to loosen them, and you probably already know what's going to happen because there's a keyhole. Unplug the motherboard, and off it comes. Easy. I cannot state just how amazingly serviceable and easy to get into this machine was. Excluding the back cover, which was 4 screws that we didn't have, it took 8 screws to get the thing down to the motherboard, and really it's just a ribbon cable that's getting in the way now. So I'm just going to unplug that, and now we can see exactly what is going on inside the machine in full detail. So remember, this is not an IBM PC compatible system, and yet here it is with an Intel 8088 sitting right here. This is the NEC D7201. This is a serial communications controller. Over here we have a Hitachi HD 46505. That is the video controller for this. This is our non-IBM compatible BIOS living right here. And this is what I also find interesting. We have 1, 2, 3 Rockwell R6522 VIAs. And on the floppy disk controller itself, we have yet another 3 R6522s hanging out over there as well. So that's 6 VIAs in total on this board. We can also see our RAM that's hiding over here. I was under the impression that these things had a base installation of 128 kilobytes of RAM. Maybe this was a factory request. So I'm seeing 1, 2, 3, 4, 5, 6, 7, 8. So there's no parity. This is 64K, 128, so this is 256K on the motherboard total. So then when you add in our memory expansion board, that gives us what, 384 kilobytes total. Other than that, it's a very clean and laid out board. If I want to remove the board from the system, and we don't have to do that, there's nothing fancy underneath of it, that's when there's a ton of screws. 1, 2, 3, 4, 5, 6 screws hold this in place, and then it's actually on plastic slides on the sides here, and then the whole thing just comes straight out and out. That's this is a really, really well-built machine. I will not put it past them that Sirius made a really fancy machine. And you can't see it hiding, but over here I have another 2-pin header. When I pulled off the floppy drives and the whole front bezel here, that's where the speaker is. That's a fairly beefy speaker. It is an 8 ohm half-watt speaker. It's an oval, and that just plugged in right there. But other than that, I'm not really sure what there is left to talk about in terms of hardware. Oh yes, the power supply. So as per usual, it is an Aztec power supply that's hiding in here. It does have reefer capacitors, so do yourself the favor while you're in there and recapping it, because you do need to recap these power supplies now. Change out the reefers while you're at it. This power supply also has this orange sticker right here, which is saying that it's currently configured for 115 volts AC rather than 230 volts AC. To change the voltage from 120 to, or 115 to 230, or 120 to 240, or you get the idea, somewhere in between, it's a simple jumper. And I like power supplies like this. Aztec was good for this at some point, and then everyone just stopped doing this because auto-ranging power supplies came along. But keep that in mind if you ever import a Sirius computer from the European Union. Make sure you're aware of that jumper or the machine won't work. Or more disastrously, if you are in the European Union and you import, say, a Victor 9000 to, I'm going to say Germany, for example, make sure you switch it over to 230 volts or you'll blow up the power supply immediately. Now I have a table that's completely covered in a dismantled machine. There's nothing more to talk about in terms of hardware, and now I'm going to struggle to talk about the software, which, well, like I said, we're going to run CPM86 or MS-DOS. So I'm going to try and give you a taste of both. Now, if you give me a moment here, I'm just going to snap my fingers and this whole machine's going to go right back together. And there we go. So now the system is back and put together. I've plugged it in. I've tried to get it set up here so it's aimed at one of my other cameras. I've had to crank up the brightness and the gain extremely high on that camera, so it does seem a little bit grainy and a little bit blown out. I apologize for that. I actually had this system demonstrated and running at ICF back at the beginning of 2024. And Josh Durish brought his CRT tester, and the helpful insight of Adrian Black from Adrian's Digital Basement helped me go through the tube just to verify if it was so dim because the tube was tired. And as it turns out, no, the tube's pretty healthy, actually. So I suspected, and we both suspected, there was capacitor issues inside of it. So I've recapped this monitor. I've recapped the power supply in the machine that powers the monitor, and it didn't really get it much brighter. If anything, I was able to fix the issue with it jittering up and down. That was definitely a capacitor issue, but, well, as you're going to see here, it's going to be kind of jank. So what I'm going to do here is reach over and turn off some of my studio lights. That way you can hopefully better see what's going on there, but now everything seems like I'm working in the dark. And as I turn it on as well, we're also going to have to deal with a loud AC fan. Immediately, it begins prompting for a floppy disk here. The screen itself takes a while to come up, which again is weird for how much cutoff there is, but eventually it does show up. There's an M, there's a 6000, and it's currently complaining about not seeing a floppy disk in there. So I am going to take one of the disks that I have and put it in here. So it's worth pointing out, originally, like I said, I only had a copy of Kermit and a bootable DOS disk that came with the machine. If you go to the Internet Archive, there's actually images of these floppy disks from someone else. Actually, I think they're the floppy disks and all that I saw from VCF West in 2023. Someone's gone and archived them and given you a directory listing. You can write those disks out with modern disk utilities. Like, I think the applesauce supports it. I don't think the CryoFlux or the Grease Weasel supports it. You'll have to double check on that yourself. But my solution was simply transfer it over to this machine here using Kermit and then writing it completely to disk. And I did that with AutoCAD. I'll show you that to you in a bit later. But if you wish to go the other route and have some more pre-made disks for you, a guy by the name of Intergalactic Microsystems on eBay is selling complete MS-DOS plus CPM disk sets specifically for this. Now, usually I don't like it when people just sell copies of software on eBay, but this is one of those rare examples where if you don't have the media for this, you are screwed. Okay, so I'm going to take CPM86 version 1.1, pop it into the floppy drive, and hit enter. Hit enter, and it's promptly going to complain at me because it didn't like that, so I'm going to hit the reset button on the back of the machine here. And you still can't see anything on the screen because it is just so bloody dim. There we go, you can kind of see something. So once this boots up here, there we go. I'm going to hit the Alt key and do up on brightness. There, that's about as bright as I'm going to be able to get this thing. Hopefully it's not blowing out too badly for you. There, I think that's good enough. So, shows up as Victor Business Systems, the Victor 9000 operating system CPM86 1.1, IO subsystem release 2.4, and the keyboard is domestic type 03, character set international type 01. Because there is obviously QWERTZ versions of this here for other locales around the world, with Europe being the most popular. These North American ones, not so much. But other than that, it's CPM for the 8088 and 8086. So I'm not sure what I can demonstrate to you here besides, ooh, look, it does everything CPM does. So instead, I have this here, which is labeled CPM Graphics Demo number 2. And if I put that into the other floppy drive and go to my B drive, remember that this thing has a Hitachi 46505 on it. So we are a little bit more advanced than the monochrome display adapter that's built in, or not built into, but available as standard on the IBM 5150. So if I want to go in here and run the demo, what it's going to do is it's going to stream images off of the disk. And these aren't just low quality images, these are actually quite high res. And they're all like not bad. There's a little bit of shading going on here, even though it is primarily a black and white display. Like there, that one's got grays on it, but it's like, sure, what, 4 grays? So like black, white, and 2 different shades of gray. But it looks really, 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 really good. I do hope it's coming across to you looking incredibly nice. But like, this is not bad for 1982 at all. For IBM, you specifically had to wait till what, the Hercules, until you had this kind of graphics coming out of it? I'm quite impressed with it. Yet unfortunately, Sir Gary Kildall, this is really the only thing I can demonstrate with CP/M, because all my other applications are ironically in MS-DOS. So I will reach over here, and I have MS-DOS version 2.1, which is typically the OEM version of MS-DOS that every other non-PC compatible had. The Rainbow 100, like the K-Pros, some company named Apricot in the UK. I don't know, let's not talk about them. And of course, here on the Victor and Sirius 1 systems. So I'm just going to pop open the system disk and hit reboot there. And I can go over here, pop in our main system disk, and it's booting off of the demo disk. Okay, no, that's not what I need there, my dude. There, go like that, pop that one out there, and we're gonna let this thing boot up into MS-DOS, which also requires me now to go back and reset our brightness as well. So that way, you can see exactly what the heck's happening on the screen, because this is more than just your typical DOS floppy booting. There we go. So we see as you're here, our BIOS version is 2.93 from November 19th, 1985. So this is quite late for the Victor 9000. MS-DOS version 2.11 HK, so OEM. We have 3 device drivers that MS-DOS added in here. So Serial A, Serial B, and Parallel. So like I said before, instead of your application talking directly to the hardware, it's talking to MS-DOS, which then hands it over to the hardware, so that your application doesn't have to be programming this in assembly, at the penalty of it's a little bit slower. Now, much like with how CP/M is really just CP/M on no matter what Z80 machine we work with, or an Intel machine in this case, MS-DOS is MS-DOS. There is nothing special about the non-PC version of MS-DOS that I can demonstrate. Woo, yeah, see, like DIR. Wow, this is exciting. Yeah, no, what, really? No, DIR, hello, there we go. So, like, there's nothing special about this. It's DOS. There's nothing fun about that. So what I'm trying to continue to do here is demonstrate the hardware. I've already shown you CP/M booting. I've already showed you some of the high-resolution graphics modes that were available. Now, I was also talking about that speaker, quite fanciful, and that's because built into this has an amazing audio system. It doesn't have the same thing that you would expect out of a SID, but when it comes to digitizing and playing back voices, you really have to hear it for yourself, and that's why I have this demo here called Talking Star Trek. And this is actually Pulse M121 from, I believe, the Sirius Victor computer software magazine. So this was available by mail order. I believe it's also available on the Internet Archive. I also believe it's available, actually it is available with the Intergalactic Microsystems software package. So I'm going to go over to B here. And can I get a DIR listing of that? There we go. So Star Trek. And what do I want? Technically, I can boot from this disk if I want to. With batch file and press D when ready. Really? Are you that upset about me? Right, so it really does want to boot from its own floppy in this case. So I'm going to let that boot up. There we go, Victor. Again, it's MS-DOS. Now we're in version 1.25, but it's still MS-DOS. And it's going to load up here. So we have the codec basic interface, which is the audio subsystem which the Sirius and Victor 9000s have, and it comes up in a very text-only looking interface. Can I brighten that up for you here? Do you need any instructions? I don't need instructions for this. Let me lean over here so hopefully you can hear this thing talk. These are all of our instructions.
This is the USS Enterprise. Her 5-year mission: to explore new worlds, seek out lost civilizations, to boldly go where no man has gone before.
This is really good, I want to point out. That sounds...
When ready to accept command, press any key.
That's a mono audio signal, audio source.
Command?
Yes, I understand. The whole game has these audio samples that are built into it, and it's using the codec engine inside of the computer, which has this beautiful replication of voice. It sounds really, really good for a machine from 1982. Wow, okay. So, other than that, though, it's a text-based game that's just Star Trek. It just has the enhancements of built-in audio. The last application I'm going to show to you here takes full advantage, however, of needing the 1.2 megabytes of the floppy drive, and that is, surprisingly, AutoCAD. Now, AutoCAD is one of the few examples here I have of major software platforms that were available to non-PC compatibles. I think there was a version of WordPerfect. I don't think there was a copy of Lotus 123, but you had SuperCalc instead, which was available by Pulsar Software, I believe. But we're going to put this disk in here, and I'm going to hit the reset button again. And this will boot back up into MS-DOS again, and it'll be pretty much ready to go with AutoCAD. See if I can brighten that up a bit. There we go. There we go. And now it wants the date and time, so I'm not going to care because it's January 1st, 1980. It's loading in the console utility there. It is going to be loading in the graphics routines here. Surprisingly, well, you're going to actually die on me here? You are going to die on me here. There we go. So apparently all that happened there is I had to take the disk out and immediately put it back in, and it was totally happy with it. It wasn't a bad disk. I don't know why. And here we go. AutoCAD 86 version 1.4 from 1983 for the Victor 9000 with advanced drafting extensions. Now I can plot a drawing on this one here. So let's do 3. And what's the name of it? I think it was called Ramboard. R-A-M-B-R-D. No drawing with that. Right. Of course, I didn't keep a list of what files were on the drive here. That's fine. It's AutoCAD, so I can go to File Utilities, List Drawing Files, which drive in Drive A. There we go. So I was looking for Ramboard. Okay, so we'll hit Return on that one there. And I'm going to exit out of that, so that's a 0. And then we're going to edit existing drawing, actually. And R-A-M-B-O-A-R-D. Hit Enter. And off it goes. Now, I'm going to give it a couple of minutes here to grind away and draw the image on the screen, because even though it doesn't use a standard IBM monochrome graphics or high-resolution graphics controller, it's still somewhat slow plotting the drawing. So I'm going to speed this up for you. And there we go. So what it did here is that included on the AutoCAD disk is some demos. In this case here, it is a Victor Sirius 512 kilobyte RAM board that could go into the machine, and that would add even more RAM to the system. But, I mean, okay, the video chip's a little bit slow here, but look at how clean that is. Look how high, what the high resolution of that display is. We are talking 800 by 400 pixels on the screen here in 1982. Okay, yes, I've been saying 1982 the entire time of this video here, even though the machine is a 1981 design, but let's just stick to this particular year. So there you have it. I've hopefully now demonstrated to you, like, sure, it runs CP/M, this is CP/M, here's the graphics that are available in CP/M. Then we switched over to MS-DOS. Yes, sure, it runs MS-DOS through that weird abstraction layer. It is able to run this amazingly clean codec voice and audio reproduction system, and we still have high-resolution, high-quality graphics that are available through AutoCAD, for example, in MS-DOS on this display. In summary, the Sirius 1 and Victor 9000 aren't bad machines. In comparison to the other non-PC compatible systems at the time, reviews on this actually said it was a fairly strong competitor. It's just a shame that the IBM PC, much like with Apple products, brand wins out overall, even if the specs are that much better. I mean, we had more base memory, we had more capacity on our floppy disks, we had high-resolution graphics, we had a smaller system than the IBM 5150, but otherwise, it didn't sell well here in North America, like I said. Instead, of course, it sold much better in Europe, like I also said as well. And while I'm not going to be talking about the availability of these machines in, say, Germany or Sweden or somewhere like that, within the United Kingdom with ACT, it turns out that the Sirius 1, or the ACT Sirius 1 as they were calling it, would be a stepping stone to building their own non-IBM PC compatible systems. But we had to start with something, and I decided to make a video on the Victor 9000 so you get an idea of what exactly it's like not having an IBM PC compatible system and just seeing just how broad of an expansive universe it is. There were so many more things the IBM just couldn't do out of the box that this thing did here. Like that digitized audio, like I know later machines can do that on the PC platform, but this was doing that at the beginning of the 80s, and that's what's mattering in this video. But anyways, I hope you enjoyed this video, and until next time, have a good one.